In this video, we will discuss solving systems of linear equations and inequalities graphically. A system of linear equations is two linear equations with one or two variables in each equation. The system is solved when we find the one ordered pair of solutions that satisfies both equations. Some systems of equations have no solutions. Others have many solutions. We will focus on systems that have only one solution. One method of solving systems of two equations is to graph each equation. The point at which the two graphs intersect represents the ordered pair of solutions these two equations have in common. To solve a system of two linear equations with two variables by graphing, first graph each equation on the same pair of axes, and then the solution will be the common point. So for example, we have this problem. A board is 20 feet long. It needs to be cut so that one piece is 2 feet longer than the other. What should be the length of each piece? So first we're going to write two equations to describe all the conditions of the problem. We'll let L be the length of the longer piece of the board and S be the length of the shorter piece. So condition one is L plus S equals 20. So that's the board is a 20-foot board being cut into two pieces. So the length of the longer piece plus the length of the shorter piece will add to 20 feet. Then the second equation is S plus 2 equals L, because we need one piece to be 2 feet longer than the other. Well, the longer piece is going to be 2 feet longer than the shorter piece. S plus 2 equals L. So now we graph each equation on the same set of axes and identify the point where the graphs intersect. And here is that graph. So this blue line here represents the equation S plus 2 equals L, and the red line represents the equation L plus S equals 20. The place where they intersect, this dot right here, is the point 9, 11. We find that the lines that represent our conditions intersect at the point 9, 11, and we can confirm that the lines intersect at this point by plugging the values into the equations. If S equals 9 and L equals 11, then L plus S equals 11 plus 9 equals 20, and S plus 2 equals 9 plus 2 equals 11, which is equal to L. When graphing two straight lines, three possibilities can occur. The two lines can intersect at just one point. This means the system is independent and one pair of values satisfies both equations. Second, the two lines might not intersect at all. This means the system is inconsistent and no pair of values satisfies both equations. And third, the two lines coincide. They're exactly the same. This means the system is dependent and the equations simplify to the same equation. So any pair of values that satisfies one equation also satisfies the other. When two intersecting lines are plotted on the same set of axes, the rectangular coordinate system is separated into four regions. The solution set of a system of linear inequalities will include all of the points in one of the regions. So to solve a system of two linear inequalities with two variables by graphing, first we graph each inequality on the same set of axes, and then the solution set of the system will be the overlapping region of the solution sets of the two inequalities. So for example, shade the portion of the graph that is represented by the following conditions. Y is less than or equal to 3x plus 5, and x plus 7 is greater than, x plus y is greater than 7. To solve this problem, we graph each line, then shade the area above or below the line, depending on which inequality symbol is used. Then the region where the solution sets of each inequality overlap is the solution set of the system of inequalities. And here's that solution. So the solution set is the purple region where the blue and red regions overlap. Notice that This line here, the red line, is solid. That means that we include this part of that line in our solution set. While the dashed line, the blue line is dashed, which means that line is not included in the solution set.